I'm Susan Shaw, and I'm going to talk to you a little bit about data mining. So what is data mining? Data mining is the process of sorting through large data sets to identify patterns and establish relationships to solve problems through data analysis. Data mining tools allow enterprises to predict future trends. Another definition of data mining is a process used by companies to turn raw data into useful information. By using software to look for patterns in large batches of data, businesses can learn more about their customers and develop more effective marketing strategies, as well as increase sales and decrease costs. The data mining process looks a little bit like this. You collect the raw data and extract it from the original source. You now have your pre-processed data. You then load all of your pre-processed data into the data warehouse. Here you explore the data and generate patterns. Tasks include table, record, select attributes, transformation, and cleaning the data in order to convert it into patterns. In the pattern store, you're determining what kinds of trends or patterns you will have with the data and begin converting those patterns into knowledge, and then you can form your database. Here are a few examples that you may have experienced yourself as you have surfed the web or conducted research. Every time I clicked on a new page to research data mining, I would get ads from Amazon, where I recently purchased a pair of boots for my son, from Victoria's Secret, the pink store, where my two college daughters love to shop on my computer, and the Baby Gap store, where I love to buy clothes for my baby grandson. So every time you shop, you leave a trail of data behind. The same when you surf the web, put on your fitness tracker, or even apply for a credit card. In fact, if we could touch it, we'd be drowning in data. The data we produce every single day, according to IBM, totals an unfathomable 2.5 quintillion bytes. That's 25 followed by 17 zeros. We're producing data so fast that it's estimated that 90% of data in the world right now was created in just the last 2 years. This big data is a global resource worth billions of dollars, and every business and government wants their hands on it, and for a good reason. Data is the digital history of our everyday lives, our choices, our purchases, who we talk to, where we go, and what we do. But data on its own is pretty useless. It's the information we extract from the data that can do everything from forewarn governments of possible terror threats to predict what you'll likely buy the next time you're at your local grocery store. The sheer volume of data available is well beyond the human ability alone to decipher and needs computer processing to handle it. That's where the concept of data mining comes in. Without data mining, when you give someone access to information about you, all they know is what you've told them. With data mining, they know what you've told them and can guess a great deal more. To put it another way, data mining allows companies and governments to use the information you provide to reveal more than you think. Nearly every transaction or interaction leaves a data signature that someone somewhere is capturing and storing. Despite the fact that the specific technical functioning of data mining algorithms is quite complex, they're more of like a black box. For the most part, data mining tells us about a very large and complex data sets, the kinds of information that would be readily apparent about small and simple things. But what's simple about 5 data points is not really so simple with 5 billion data points. And there's always more data. We gather far more of it than we can digest. Nearly every transaction or interaction leaves a data signature that someone somewhere is capturing and storing. Data mining is a means of automating part of the process to detect interpretable patterns. It helps us see the forest without really getting lost in the trees. Discovering information from data takes 2 major forms: description and prediction. At the scale we're talking about here, it's hard to really know what the data shows. Data mining is used to simplify and summarize the data in a manner that we can understand, and then allow us to infer things about specific cases based on patterns we have observed. Of course, specific applications of data mining methods are limited by data and computing power available, and are tailored for specific needs and goals. However, there are several main types of pattern detection that are commonly used. These general forms illustrate what data mining can do. The first is anomaly detection. In a large data set, it's possible to get a picture of what the data tends to look like. in a typical case. Statistics can be used to determine if something is notably different from this pattern. For instance, the IRS could model a typical tax return and use anomaly detection to identify specific returns that differ from this for review and audit. In association learning, this type of data mining that drives the Amazon recommendation system. For instance, this might reveal that customers who bought a cocktail shaker and a cocktail recipe book also often buy martini glasses. This type of findings are often used for targeting coupons and deals or advertising. In cluster detection, one type of pattern recognition that is particularly useful is recognizing distinct clusters or subcategories within data. Without data mining, an analyst would have to look at the data and decide on a set of categories which they believe captures the relevant distinctions between apparent groups in the data. This would risk missing important categories. With data mining, it is possible to let the data itself determine the groups. This is one of the black box type of algorithms that are hard to understand, but in a simple example, again with the purchasing behavior, we can imagine that purchasing habits of different hobbyists would look quite different from each other. In classification, if an existing structure is already known, data mining can be used to classify new cases into these predetermined categories. Learning from a large set of pre-classified examples, algorithms can detect persistent systematic differences between items in each group and apply these rules to new classification problems. Spam filters are a great example of this. Large sets of emails have been identified as spam and have enabled filters to notice differences in word usage between legitimate and spam messages and classify incoming messages according to these rules with a high degree of accuracy. Here's some examples of data mining in business. The first is service providers. Mobile phone and utility companies use data mining and business intelligence to predict the churn, or the terms that they use when a customer leaves or cuts ties with their company to get perhaps their phone, gas, or broadband from another provider. They collate the billing information, their customer service interactions, website visits, and other metrics to give each customer a probability score. And then they target offers and incentives to customers whom they perceive to be at a higher risk of churning. Another example of data mining in business intelligence comes from the retail sector. Retail segment customers into three major groups: recency, frequency, and monetary, which if you've had marketing classes, I'm sure you've heard about that. In those three groups, they offer marketing and promotions to those different groups. A customer who spends little but often and did so recently will be handled differently than a customer who spent a really big amount only one time and quite a while ago. The former may receive like loyalty, upsell, and cross-sell offers, whereas the latter may be offered a win-back deal. Perhaps some of the most well-known examples of data mining and analytics come from e-commerce sites. Many e-commerce companies use data mining and business intelligence to offer cross-sells and upsells through their websites. One of the most famous of these, of course, is Amazon, who uses sophisticated mining techniques to drive their people who viewed that product also like this product functionality. Supermarkets provide another great example of data mining in business intelligence in action. Famously, supermarket loyalty card programs are usually driven mostly, if not solely, by their desire to gather comprehensive data about customers for use in data mining. One notable recent example of this was with the U.S. retailer Target. As part of its data mining program, the company developed rules to predict if their shoppers were likely to be pregnant. By looking at the contents of their customer shopping baskets, they could spot customers who they thought were likely to be expecting and began targeting promotions for diapers, wipes, and other baby items. The prediction was so accurate that Target made the news by sending promotional coupons to families who did not yet realize or had not yet announced that they were pregnant. The use of data mining and business intelligence is not solely reserved for corporate applications. Beyond corporate applications, crime prevention agencies use analytics and data mining to spot trends across huge numbers of data, helping with everything from where to deploy police manpower, who to search at border crossings, and even which intelligence to take seriously in counterterrorism activities. Here's some examples of data mining through social media. Social media sites such as Facebook, MySpace, LinkedIn, and Twitter are data mining gold mine for readily available personal and sensitive information made publicly for the web, especially when the majority of the participants are using default privacy settings. Given this enormous volume of social media data, analysts have come to recognize Twitter as a virtual treasure trove of information for data mining. Social network analysts and information for sensing public opinion trends and groundswell of support or opposition for various political and social initiatives. Twitter trend topics are becoming increasingly recognized as a valuable proxy for measuring public opinion. The example I want to look at now is of data mining for predictive social network analysis using Twitter. We're going to look at the 2014 Brazil presidential runoff election that was held in October of 2014. Data mining was used to extract Twitter trend topic data from 14 Brazilian cities to get the top 10 Twitter trend topics for those 14 cities in 20-minute intervals. Python and a Twitter library were used to get all of the social network data for the day of the runoff election and 2 days prior to the election. There were 17 queries performed. This is an example of what the object return in response to each query looked like. A network was created using the following rules. Each city was a node. If there was at least one common trend topic between the two cities, then there was a link. Each link was weighted according to the number of trend topics in common between the two cities. So the more trend topics two cities had in common, the heavier the weight attributed to the link between them. This example showed how social media and data mining can be used to extract information and look at trends for a specific group of people in a specific area. In another example I want to explore, we'll look at the 2017 Kenyan presidential election that's actually going to be held in August of 2017, which is just now, right around the corner. This example will examine attack ads and data mining. In this example, a toxic campaign ad was unleashed online in Kenya just weeks before national elections, a potentially explosive move in a country where politics and ethnicity are closely aligned. A 90-second video was launched on social media which presented dystopia in Kenya. It showed Odinga, who's the leading opposition candidate, winning the August vote, and the nation is forced into a violent dictatorship. The video made quite a stir, as you can imagine. Many believe that Cambridge Analytica is behind the video. This is the company that is credited with using data mining and psychological profiling techniques to help swing recent votes in, you guessed it, the United States and Britain. They, of course, denied the claims that they were behind the video ad. With 7.1 million Facebook users and an estimated of 2/3 of Kenya's 45 million people able to access the internet, there is a critical mass of people leaving an increasingly detailed trail of information about their fears and preferences, a rich resource for those seeking to influence voting choices. Cambridge Analytica was behind political research in 2013. This information collected segmented the Kenyan population into key target audiences. There are fears today that the data that was collected in 2013 will be used to tailor specific messages to the voters. This leads to further concerns of the integrity of the data being stored and who has access to it. Another major concern in Kenya is fake news. Fake news has dominated political discourse in the United States and is now being utilized in the Kenyan election. Jeffrey Smith, who's the executive director of the US-based Vanguard Africa, an organization that promotes free and fair elections, has been under attack since he invited Odinga to the United States in March to meet policymakers. It is said that fake letters are circulated on the social media with the help of trolls and bots, with the intent of rigging Kenya's election for Odinga. Smith said at least once a week he will wake up and have hundreds of Twitter notifications from accounts that are clearly bots and trolls tweeting in a coordinated manner, posting the same bogus and entirely false information over and over again. So what does all this show? We looked at several examples of how data mining works. It can affect us when we're surfing the net or even conducting research. It's used by the government for auditing purposes, by retailers for marketing purposes, by law enforcement agencies to spot trends. It's also used in politics to view trends, in social media, and even sway elections. So how can we prevent data mining? Well, there's a few things you can do. You can be careful what you share. When joining online services, just be aware of the information you submit. Don't sign up if the subscription form demands more personal details than you're ready to provide. And always assume your data will be traded. Although privacy policies tend to claim otherwise, the fact is that once your data is out there, it's really not safe. Also, assume nothing is free. Many websites and online services advertise that they're free. While that may sound enticing to be able to use a certain service free of charge, just be aware that that's rarely the case. So here's some tips that you can do to hide your digital footprint. You can use a temporary email address. For services that you're just trying out, once you decide that you like the service, change that email setting by switching to your subscription-only email account. Open a permanent subscription-only email account and use it for services that you deem subscription worthy. This will greatly limit the amount of spam and ads that you get on your private email. Whenever you can, answer with not applicable on any subscription form fields that you deem unnecessary for the service provider to know. Don't write your email address on forums and directories that display it for all to see. That makes the data available to spam bots and scripts. Avoid installing adware and infecting your PC with something worse, so don't download software from unreliable sources. The Do Not Track feature that most browsers have is very useful. And then there are also several search engines that you can surf the net through that will help you get to the dark web if it's your desire to go undetected. You can use stuff like the Tor network or DuckDuckGo. So if you really want to browse the net without leaving the trace, likehacker.com has some tips that help you learn how to live off the grid if it's your choice to do so. I hope this was helpful for you, learning a little bit more about data mining, and I hope the tips were helpful as well. Thank you so much.